Yeah. He's really cool. We talk a lot. Hey, listen. We talk a lot. He sends me news stories that he finds are pretty cool because I used to do the news stories all the time. I haven't had time to do them this year too much. Yeah, he sent me like an email with a link to it. So, oh yeah, thank you.
I still like in the sticker.
I got a cord running over there to my iPad. So I can go back and forth.
You can touch screen now.
You're representing.
Yeah, I'd like
No, it's.
Just break this one. Wait, how come some teachers got new ones and some didn't?
if they break, they replace it with a new one instead of fixing it. So no, we ain't doing that. And we're recording right now, so I wouldn't admit to doing that anyways. Johnny. So listen, I had this news story today. He sent me, and I read it during activity period. And it just fits in perfectly with what we were talking about yesterday, and what we're gonna be talking about pretty soon. So I want to go through the news story with y'all and kind of talk about what it means, how they figure this stuff out. It's not a long one, but it's pretty interesting. So the headline says. So first off, he finds these from ScienceDaily.com. It's just a bunch of science news. If you're interested, you can go to the website and check out some cool science news every day. So this headline says, exploding stars may have caused mass extinctions on Earth, this study shows. The reason I want to talk to y'all about it today is because we literally just talked about how mass extinctions are how scientists separate one geologic period from the next. So when does one begin? When does the other end? Usually we look for something where it's a worldwide phenomenon, and a lot of times those are mass extinctions where a lot of species died, and then after a lot of species die, you have a lot of open niches in the environment, so new species come and fill their place. Like we saw yesterday as we were rearranging those things, mammals came about during the time of dinosaurs, but the dinosaurs were kind of ruling the earth in a way, especially biologically in their place as predators. And so it wasn't until after the dinosaurs died off that the mammals were really allowed to flourish and become, kind of the dominant species of the planet. And so it all depends on what kind of predators you have and what kind of hierarchy you have in the food chain. So this basically deals with a mass extinction, not caused by a meteor or by sea level rise or sea level drop or a change in temperature, but by an exploding star nearby. We've already talked about stars and supernovas, and you've even had a couple questions about how close they need to be for us to be able to see them. So let's go through this. First off, one of the things I like about this is actually like based on the scientific paper. So it's less like somebody trying to spin something and more like them trying to actually give you the heads up. So it says, imagine reading by the light of an exploded star, brighter than a full moon. It might be fun to think about, but this science is the prelude to a disaster when the radiation devastates life as we know it. Killer cosmic rays from nearby supernova could be the culprit behind at least one mass extinction event, these researchers say, and finding certain radioactive isotopes in the Earth's rock record could confirm this scenario. So this is from the University of Illinois in Urbana-Champaign. Champaign is a city in Illinois. I think Urbana might be also, so it's a college for both towns. So this is an astronomy and physics professor, Brian Fields, and he explores the possibility that astronomical events were responsible for an extinction event 359 million years ago, right in between the Devonian and the Carboniferous. And we talked about the Devonian and the Carboniferous yesterday. Basically, what they find when they look in those rocks, they find plant spores. So spores are like they're a way of reproducing plants before we really got seeded plants. Another way to think about plant spores is almost like pollen from plant. You can have pollen grains, or they sometimes even call them pollen spores, I think. So you have plant spores, but they appear to be sunburnt. And that is not a usual thing. Usually plants are pretty good at dealing with sunlight in a normal way. And so to see things that look like they're damaged by the sun kind of stands out to you if you're this kind of scientist. So what those sunburnt plant spores mean to them is that we had an abundance of ultraviolet light, UV light, which is bad for you. We use sunscreen to kind of block out the UV light. And so that's evidence that it wasn't just a short time, but there's a long-lasting ozone depletion. And y'all have all heard about the ozone layer and everything, right? Yeah, you want to protect the ozone layer. Y'all pay attention. Stop talking. If you got questions, ask me. All right. So basically, they're looking in these rocks. They find this evidence and they go about to try to figure out if it actually happened or not. Their idea is they propose that one or more supernova explosions about 65 light years away from Earth could have been responsible for this. Why do they say one or more? Basically because as they're looking at the time frame, this happened over a long period of time. They think that just a normal supernova at that distance would have messed up the Earth's atmosphere and given us this extra UV radiation for about 100,000 years. But we see that it's actually happened for 300,000 years. And so they think it might have been more than one, like back to back to back. How could that happen? As we look out into space, there are clusters of stars that are actually pretty close together. And what they're saying is if one of them goes supernova, it could kind of trigger the other ones to become unstable, and they could go supernova shortly afterwards. So if you kind of stacked several supernovas back to back to back, you could get this long-term devastation of Earth's atmosphere, and that allows more UV rays to come in. Also, something I know you've asked before, how close would a supernova have to be to really affect us? Well, they're saying 65 light years away would have messed up our atmosphere for quite a long time and created these effects. 25 light years away is what they call the kill distance. So if it's 25 light years away, it's going to cause a whole bunch of problems and actually maybe kill most of the things on Earth. Where this 65 light years away for a longer period of time still caused a mass extinction event here on Earth. Yeah.
So a supernova is kind of like a nuke, but in space.
Yes, yeah, but much bigger than a nuke, bigger than anything we could ever create. It's crazy.
All it is a nuke that's sitting there building up.
They do point out that this is not a normal thing. Like today, as we look out at all the stars around us, the closest star to us that has the possibility of going supernova is Betelgeuse, which is about 600 light years away. So even that is very, very far away. They do think that it could happen like literally any year now because it's been doing a lot of weird stuff. But that one's way far away, way much further than the kill distance or than the 65 light years they think these were.
Can they
So-
video it? We would see that one. Can they video it?
Yeah, we're looking at it all the time. So if that one does go supernova, we will be observing it when it happens.
Okay, so would we know the moment it went supernova, or like could it have?
No.
Could it have?
We would know-
We're just waiting for the light to come.
We would know 600 years after it happened because it's 600 light years away. So if anything changes on it, whether it's going supernova or anything else, we don't get that information until 600 light years
So
later.
it could already exploded 599 years ago.
Yes, and we're just waiting for it to happen. Yep. Yeah.
That's so cool.
Yeah. That's the way light travel works. In far distances, it's not just a distance, it's like a time distance in a way.
So it already exploded, you're saying?
Possibly, we don't know. We don't know. But all we know is from when the light gets here. That's the only way we can know. Now, if we send a spaceship towards there, that spaceship might know before we know, but still, it would have to send us a signal, and that signal travels as radio waves, which travels at the speed of light, so we still wouldn't know until the exact same moment. There's no way for us to figure it out faster unless a person physically goes there, but they wouldn't even be able to tell Earth any faster. It would just be like it is. Yeah.
Just turn, take a metro tower.
Yeah. Now there's science fiction stuff where people are able to talk like instantaneously, but that's not real. And if you think back to like The Martian, he's trying to communicate with Earth, and it takes like 15 minutes for his signal to get here, and then 15 more minutes for it to get back to Earth.
I thought it was like a day or something. I thought it was a lot more than
I don't think it's that long because it only takes light from the sun 8 minutes to get to Earth. And so I think they had a 15-minute delay from Earth to Mars. And that might have been both ways. Yeah, it's a long time. It's like, if you're talking with somebody on the phone and there's even like a 3-second delay, it's infuriating. You're like, can you hear me or not? What's up with this? So yeah, having to wait that amount of time is kind of a big deal. So how do we know? How are they able to prove this instead of just having it be a theory? I was a little disappointed because they have a way to prove it, but they're like, we're not going to do that. So what they're saying, well, let's go through it. The team said the key to proving that the supernova occurred would be finding specific radioactive isotopes, which are plutonium-244 and samarium-146. Samarium. I've never even heard of samarium. Where's samarium at? Just for my own information. Samarium. There it is. Number 62, samarium. So it is a real, they're not lying to us. It's a real element. The Army confirms it. So samarium 146, these are radioactive isotopes. And as far as we understand, there's nothing on Earth that can create these radioactive isotopes. They can only be created in gigantic explosions in space. And the way he describes it, which is going to sound funny, but remember, they're from Illinois, because people from Illinois are kind of funny. He says, radioactive species born in this supernova are like green bananas. When you see green bananas in Illinois, you know two things, that they're fresh and that they're not from around here, because they don't grow bananas in Illinois. And so if you have those two things, you know that it came from somewhere else. And that's basically what these radioactive elements are. If you find them in that layer, you know that they're pretty fresh because they're radioactive. If you give them long enough, they'll decay into something else. They won't be these radioactive elements anymore. They'll be something else. And if you find them in that rock layer, you know they're not from around here. They came from some sort of explosion out in space, and they got here later.
How long would it take them to decay?
We can actually look that up. Plutonium is going to have like a half-life of probably like hundreds of millions to maybe billions of years. And I don't know about samarium. I can look it up though real quick and find out. In fact, let's see. I'll do one of them. But let's do plutonium-244. Or you want to do samarium? Samarium 146. Go to Wikipedia page. Isotopes of samarium 146. The half-life is 6.8 times 10 to the 7 years. So let me just write that on the board real quick. 6.8 times 10. Oh, I got no marker.
Oh, that's a lot.
Here we go. I got one right here. 6.8 times, what is it, 680 million?
Oh, yeah.
Yeah.
It would be
6.8 times 1, 2, 3, 4, 5, 6, because it was 7.
Yes.
So 68 million years. Yeah, 68 million years is what it takes. And that's just for half of it to decay into something else. You would still have half of that samarium left over. So these elements, plutonium and samarium, are long, relatively long half-lives. But that being said, when you're talking in Earth years, the Devonian was 359 million years ago.
Oh, so those
So these would be like fresh bananas, like your green bananas. It's still there. Tells you that it happened somewhat recently. So, but later in the story, they basically say that they're not gonna. Researchers have yet to search for these two in rocks from the Devonian Carbonaceous period. Fieldstein says his study aims to define the patterns of evidence in the geologic record that would point to supernova explosions. Basically, they haven't started looking for it yet, which is a little disappointing. I want you to be out there. This interview should be conducted from the field as you're looking for these. I want to see some action. they're basically like, yeah, we discovered this thing, but I'm just gonna stay here at the university.
Tease.
Yeah, let's get some action going. Let's find these things. But I thought that was a cool news story. We're gonna segue at some point in time. I think in this unit, we will start to talk about radioactive decay and using these radioactive elements to actually date rock layers. Well, they're radioactive like the Hulk, but they're not like the Hulk. Yeah. You won't turn into the Hulk. You'll just get sick and die. No. But yeah, we're going to talk about radioactive decay and how we date rocks using radioactive elements and how we date rocks using relative dating where you kind of put them in order. So, yeah, I don't think I'm going to lecture on discovery education today. We do have this constructed response assignment, so it's only 2 questions. In fact, let's take a look at it.
No, it's only 2.
So yeah, there's only 2. You can go ahead and get started on it. The first one says, Earth's history, known as geologic time, is described by the geologic time scale. Lists the 4 types of major divisions of the geologic time scale. So they're talking about the eon, the era, the period, and the epoch. And they want them from longest to shortest. So make sure you get that right from longest to shortest. It should be in the reading. I assigned the reading, so you can go back and click on the reading. It'll take you to that section that we went through on Tuesday. It says, describe the scientific dating methods, including sequencing the rocks and fossils used to construct the geologic time scale representing Earth's 4.6 billion years. They probably go over that. I'll make sure in just a second that they actually give you some information to answer that. And then it says, give an example of a general type of geological or ecological event that scientists use to mark the boundaries between divisions of the geologic time scale. Then give a specific example. So the general type is like basically what we just talked about. And then they want a specific example. So find one in particular that marks the boundary in between 2 specific geologic time frames and talk about that one just briefly. It doesn't have to be super long. So let me go back to the reading just for a second and make sure. So the reading's deep divisions of geologic time. Let's make sure they talk about the methods. Because I don't remember them talking about that. It's probably up near the top. Yeah, it's kind of up in here. They talk about fossil evidence. They talk about the radiometric dating. And well, I guess that's it. We just go through all the times. Well, we did kind of mention this. So I don't think they talk about the radiometric dating a little bit, and you might be able to click on this to get a little bit better information. But here, just to go over it briefly, we drew this the other day, and I talked about how you find the horse fossils, you find the trilobite fossils. Which one's going to be older?
The
trilobite. And why is that? Because what is on the bottom?
The oldest.
The oldest layer is on the bottom, and the youngest layer is on top. And so as we find these different fossils, we put them in relative order. That's the relative dating, is which one's older, which one's younger, and you try to find different fossils that kind of confirm that. And so using that law of superposition, you can kind of figure out which is oldest and youngest. And we use that compared with the radiometric dating, because you're not going to find radioactive elements everywhere. You only find them in specific layers. So we can date some of them exactly, and we use the relative dating to do all the stuff in between. All right. If you have any questions, let me know. But that's the assignment for today. And everybody enjoy their weekend. And beat Edgewood. Yes. Yeah. Let me see if it's submitted.
I should read it. Because these are still. So,
Yeah, even my table.
kind of. Well, never mind.
Yeah. Well, that I don't know that gets
Did
saved.
you do
I think when you come back in, that
Yes. I got that first part.
hold on, let me.
I got.
Well, I guess it's not gonna show your grades and stuff. Let's see. Oh, let me go back to view.
I don't know what to put.
What? Are y'all serious right now? Where you at? Where you at? Where you at? Nah, it doesn't look like it got you. Now, it does, to be fair, it doesn't look like you got most of the class. Y'all need to go back and make sure that you got all your questions submitted, on the exploration thing we did yesterday.
Is one subject?
Jose, I got both of yours. Johnny, Hannah, and Gage, I got the second page for y'all, but not the first page.
Maybe you have to turn in both.
Oh,
You gotta turn in both, yeah.
I press save and but I press save and exit.
Yeah, just brought the door.
Did you press save?
So look, there's no due date on this.
On the thing?
It's always open. So if you gotta go back and put some more answers in, you can do that. Remember, I recorded that video, so where we went through everything and I kind of went through all the answers. So if you need to go back and look at the video, it is on Google
Wait,
Classroom
which
for y'all.
You gotta go to the assets. View assets.
I'll send that email out 'cause it looks like some of the online people had some issues too. Sorry about that. I wish they would just submit everything.
How do I get back to that?
Yeah, for real. I don't even know.
Hold on, I'll open up the view assignments. Edit date,
I didn't save my part.
and I'll put it in through the weekend.
What?
That's dumb.
I saved the next. I saved
It didn't save any of my stuff.
Give me the
For real?
answers.
Yeah, it didn't save.
Yeah, I don't think it does save
It
it.
probably didn't save mine.
look,
either.
You press save and exit.
What's it called?
It wouldn't let me.
It
It
saved
saved my second one, but it didn't save my first.
What's it called?
Johnny, if you just go to your past due,
It
Yeah.
didn't save mine because I hit submit.
Yeah, it says it
loading
says-
do it. Just kept loading. And I just opened it up in this class and it didn't save it.
So if you click on this,
You
I
gotta
changed the due
go
date,
to
so it should
completed.
pop up now. If you click on this view assets, it'll
Let me
take you to the page. You scroll down to the bottom and click on exploration.
I can't read.
And that video on Google Classroom not only has most of the answers, but it shows you how to get to the assignment too.
Where the heck is that?
Or if you have questions while we're here in class, I can do that.
You what? Yeah.
Sorry, y'all.
Wait, did you get one?
Let me see.
Man,
So you just need the first page?
I guess so.
Let's see.
I have the first page.
Sherry, I got your first page.
That's dumb.
I know.
Yeah.
I didn't get your second page, Sherry.
What is the primary difference between
Wait, what are we doing? It's gonna get down on
them and
my
the
list of four types. If I do it, I'm gonna do
Oh,
it.
that's gonna be in the no, that needs to go in the top box.
in
It
the
didn't say
Yeah,
either
just
of
cut
my,
it and
either of my
paste it.
pages though. But, yeah.
it just didn't save the first one.
But the thing is, I never closed it out. I kept it open off my.
So dumb. Nope.
It was.
I submitted mine, but
I'm just gonna do
What did it mean on the second?
okay,
Look,
how
this
do you
was
say
this one.
that?
I was answer to. I thought it was this one.
So
Eight.
what you have right there is kind of like the second answer. The first answer would just be that, one of the things scientists use to make that division is meshes. So the first question is just more general, like how do they divide things up? And then the second one's more specific, like you already got the Permian area masses. Yes. Yeah, that's exactly what they're looking for. And so just give me something like, well, instead of just that, maybe put, Joe just used mass distinctions to make the divisions in geological time. You find one, like an actual mass extinction that happened at one of the boundaries. Yeah, but look up like a specific one, or go to the reading and they talk about them in between some of the divisions of geological time.
No, because we use radiometric dating.
Sorry, y'all. If y'all have any questions, you can email me, or remember that video is up there on Google Classroom. That'll help you get everything submitted. And I can't like assign this or put a due date, so it's gonna be open all weekend or even into next week if you need time to work on that. Well, no one thinks I'm touching the refill.
Oh, what the heck?
Oh no, my video is still recording. So if you made it to the end of this video, please make sure that everybody goes back and make sure you got your exploration from yesterday submitted. If you didn't hit submit on both of the pages, it probably only submitted half of your work. So make sure you go back and get that done. And if you have any questions, please email me. And everybody have a nice day and have a nice weekend.